Hey, what's going on, guys? So, everything that's going on today is just like another day review for homework number 14 because I told you guys that homework number 14 was really supposed to be a test. So, lesson 16 that we're going to go through, again, I'm only going to do the first page today, but a lot of the questions are going to look very similar to what we are going to see on that homework 14. So I'll go through them. If you guys got questions, make sure to contact me. Homework 14, I made the due date and show be for Wednesday, which would be the 6th. Okay. So I mean, there's a lot of stuff going on this first page. I'm not going to do all of them because, for one, I crossed some of them off from the packet, and others, there's like 2, 3 parts. And if I show you guys one, I won't have to do them all. Okay, so first one I'm going to do with you guys, it's going back to just evaluating, plugging in, substituting. I don't think I'm going to have to do a crazy amount of these because it's just substituting in, and I just need to make sure you remember your exponent rules. For the most part, you can do it into the calculator, but I'm going to do them all by hand. So the first one says that you have a equals 9. So I'm just going to plug 9 right into that expression, and I'm going to have 3 times 9 to the 0 plus 9 to the negative 1/2. The left side, 3 times 9 to the 0. If we follow order of operations, anything to the 0 power is always equal to 1. On the right side, we have 9 to the negative 1/2. Now, again, I'm not using a calculator when I go to solve these out. You can type it into the calculator, you can get your answer, and you'll be good to go. I'm going to do it by hand. So when I go to do this, we're not allowed to have negative exponents. Negative exponents are bad. So what we did is we flipped it over. So what I'm going to do is I'm just going to make this 1 over 9. And because we flipped it, the exponent becomes positive. There's still one other thing we have to do, and it's a phrase that we did in the past called down and out. The proper term is power over index. So what we're actually doing is we're changing it back into radical form. So the left side, again, 3 times 1 is just 3. But when we go to change this into radical form, what we're actually doing is just taking the denominator and bringing it to the outside. So I use the phrase down and out because we took that 2. And what we're going to do is we're just moving it to the outside of a radical. The 9 to the first power stays on the inside. Now this is just a simple square root now. It's square root of 9 to the first power. Well, the square root of 9 is just 3, and 3 to the first power is 3. So this is really just 3 plus 1/3, which we can just say is 3 1/3. Or if you did this in your calculator, it would come out to be 10 over 3. Okay. Part B is the same exact type of steps. You're just plugging 64 in for the A. The first part, again, is going to be easy because you're raising it to the 0 power. It's the right side where you're doing a little bit of down and out. Okay. So I'm just going to do part A. I'm just going to leave it there. If anybody wants part B done or wants some more practice solving that out, just let me know. But like I said, just use your calculator if you need to. Number 2, we haven't done factoring cubics in a while, so that's why I put a couple on here. I'm going to do A and B because one's positive, one's negative. So just color code it. This one's the positive, so this one is considered the positive because it begins with A plus B. This one is the negative because it begins with A minus B. So the first thing that we had to do is figure out what the A's and B's are for these functions so we can plug it in. So in order to do that, what I'm going to do is just find the cube root of both of those. So I'm going to find the cube root of x cubed and then find the cube root of 27. Well, cube root of x cubed, and actually I forgot to put the little 3's out here. They're cube roots, not square roots. So the cube root of x cubed is really just x. And because that was the first term That was the first thing that came. I'm just going to say a is equal to that x. And that 27 is the second term, so that's really the b value. And the cube root of 27 is really just 3. Now that we know what a and b are, we're just going to take those and substitute it into that positive cubic expression. So I know a was x plus the b value, which is 3, times we have a squared, which would really just be x squared, minus a times b, which would just be x times 3, or 3x, plus b squared, which would just be 3 squared, which is 9. If you have to take a math course next year, odds are you're going to have those parentheses memorized. I didn't have you guys memorize it this year, being that it's Math 12, pre-college. I gave you guys formulas throughout the year. Next year, I don't know. It depends on your professor. That's all I can say. As far as part B goes, I'm going to do one like that just to show you guys that because the subtraction sign's in the middle, we're really going to be using the second expression. So I'm still going to use the same first step. I'm still going to cube root both of these. If you're cube rooting x to the 6, you're just splitting it in half. You're splitting it into 2 pieces. So the a value is really going to be x to the 3rd, because we're just cutting it right down the middle. If you do cube root of 64y to the 3rd, well, cube root of 64, if you can't do it off the top of your head, you have your calculator, but the cube root of 64 is 4. And then the cube root of y to the 3rd power, oh wait, why did I cut it in half? I got to change a. I don't know why I said cut it in half. We got to cut it in thirds. This is going to be 4y. That's not going to be x cubed because we're doing cube root. I was doing square root off the top of my head. If you square root something, you're cutting it in half. You're cutting the exponent in half. If you're cube rooting it, you're cutting it into thirds. We're dividing it into 3 pieces. And if we divide it into 3 pieces, it should be x squared. My bad on that one. Because if you have x squared times x squared times x squared, you'll have 2 plus 2 plus 2, which is x to the 6. Now that I have my a's and b's, I'm going to substitute it in. This is one big thing that I wanted to go over because a lot of people throughout the year was making this mistake. The first parenthesis is just a simple substitute in, x squared minus 4y. It's the second parenthesis that you guys have to be careful with because you're squaring all of it. So the first part, it says a squared, so you're really doing x squared squared, which would really mean you have x to the 4th power, plus the next part says that you're going to have a times b, which I write it alphabetically, so it's going to be 4x squared y. It's this last piece. It says it's b squared, and a lot of you guys throughout the year would just say that the answer is 4y squared. The reason why that's incorrect is because you're squaring the 4 and the y. So it shouldn't be 4y squared. It should be 16y squared. And then you guys are done. There's nothing else that you can do here because that parenthesis, that second parenthesis, cannot be factored. Okay? So the same thing would happen in that last one. I'm not going to do it though because it's just the same process on a repeat using those 2 expressions. Okay? Number 3, this was going back, multiplying coefficients, and then having bases with exponents. So in this one, there's 2 steps to the one rule. If it's multiplication, you just multiply the exponents. Multiply the coefficients and add the exponents. So I have 4 times 6, which is going to give us 24. Now, because the bases for those exponents are the same, they both have x's, we're allowed to just keep the x. And then we're just adding the exponents together. Just make sure when you're adding the exponents, you're adding like terms. So you have 3c plus 2c plus 5. The only thing we can combine are the c's. So that would be 5c plus 5. And that's it. Don't overthink those ones. That's just a simple multiplication, okay? Same thing's going to happen over in part B, unless my notability is going to crash. I didn't have any issues with my lesson earlier. I thought I fixed it. That's the first freeze I've had today. Same thing's going to happen over here. You're just multiplying the coefficients. In this case, there is no coefficient out in front of the x to the b power, so it's really just going to stay 2. And then, again, we have the same bases, so the x is going to stay there. And then you just combine like terms as far as the exponents go. So it's just b plus 6b minus 4, which in this case would be 7b minus 4. And that's it. And I'm pretty sure I left one question like that on the homework number 14. I think it's homework number 14, yeah. Okay. Number 4 I took off completely. Don't worry about those. That's just more practice with the down and out stuff. Being that this is all on the computer and you guys have to do it all digitally, use the calculator if you have to use the calculator. I'm not going to force you guys to not use it. So that's just going to leave us off with question number 5. So it's a piecewise function. We've done piecewise functions already throughout the year. This is going through writing the formula. So this is for anybody that's still struggling writing the formulas out. So right now we know that there are 2 pieces to the formula. We got this piece and we got this piece. We just have to figure out what those 2 equations are and then find the intervals. So before I even start writing out the formulas, let's look at the blue one that I highlighted. And the 2 things we have to find for that equation are the slope and the y-intercept. So I can't do anything unless I know what m and b are. I always start with b because b, y-intercept, where it crosses the y-axis. And in this case, it has an open circle on 2. As far as the slope goes, it looks like I put down the 2 points, -2, 0, and 0, 2. So it just looks like it's going up. It's supposed to be going up 2, but it's not showing the line, and then over 2. So if it's up 2 over 2, that's 2 over 2, or just 1, because it's going up 1 over 1. So I can create an equation with that. It's just going to be y is equal to 1x plus 2. You don't have to put the 1 there because it's 1x, which is really just x. I'm going to do the same thing for the one I highlighted in red. I need to find my m and my b. Again, b value, this one you guys can see crosses right at the origin. So the b value is really just 0. And then the m value, once again, is up to over 2. And again, 2 over 2 is really just 1. So again, I could write down the equation for this one. I have y equals 1x. And it's going to be plus 0, so we don't even have to put the 0 there. So we have the 2 equations, but they're not the full equations. They're only pieces. So if I want to draw out the piecewise function, that's where that squiggly bracket came into play. We had y equals. So the first equation was the blue one, and we said that that is just x plus 2. Second equation was just x. So that's the equation as a whole. We just want the piece of them. So we need to know the smallest piece all the way to the largest piece. So if I'm looking at this first one, the smallest is the arrow. And I've always told you guys, if you ever have an arrow in math, that means it's going on forever. So that's really going towards, in this case, negative infinity. So the smallest value for the first function would be negative infinity. Negative infinity can never have an equal sign, so it would just be less than x. And we're going all the way up to the value of It looks like it stopped at 2. And in this case, 2 is an open circle, so there's no equal sign on that either. So for the first equation, we're done. Now we got to do the second equation, and in this case, the smallest value right here is at the origin, which is at 0. So the smallest number is going to be 0. And now we're going all the way to the largest value, which, again, if we follow the line, it is an arrow, and that arrow is going to positive infinity. In this case, the 0 is going to be closed because it is a closed circle, so we have to put an equal sign with it. But again, infinity goes on forever, no equal sign. So what we did is we just created the formula for this piecewise function. Okay? Oh, yes, I'm sorry. Thank you, Hannah. Hannah pointed out I put down the y value. Hannah said, nope, you're perfectly right, Hannah. So this part right here shouldn't have been 2. I wrote down the y value. And when you guys do intervals, you should be doing the x values. So if I'm looking at this open circle up here on the y-axis, the x value is at 0. Thanks, Anna. So I'm going to leave it off at that point today. So I pretty much did the whole first page with you guys. Tomorrow we're going to go the other way and create the piecewise. And some people have pointed out to me that the homework questions are exactly the same as these review questions. So I might just, I'm not going to solve 7 and 8 with you guys tomorrow, but I'll kind of guide you through and make sure that you guys can at least figure out the steps for them. Okay? So that's all I got. I will see you guys. See you, Hannah. Hit me up if you guys have any questions, and I'll catch you guys later. Have a good night.